Hi everybody, Mr. Garrett here, and we're going to go over the two review problems that I asked you to do for 11.4 and 11.6. This first video will cover the one from 11.4, and the second one will be for 11.6. So the first question is talking about retirement and how long you're going to retire and so on and so forth. And so the question reads, you're 25 and just landed your first real job. Now it's time to start thinking about retirement, of course. Figuring you plan to work until the ripe old age of 65, a mere 40 years away, how much must you save every month in order to retire comfortably? Retiring comfortably by your definition is living until you are 90 years old, 25 years after retirement, and withdrawing $6,500 per month during that time. Now let's talk about investments. While you're saving for retirement, you are fairly aggressive and make some good investments, averaging 10% per year compounded monthly. Once you retire, you conservatively move your investments into a much safer portfolio, averaging 4% per year compounded monthly. Now, I kind of left this out, but you need to figure out how much do you need to save per month while you're working for this scenario to happen, and we'll work on part two in a minute. So let's start with part one, and we're going to go ahead and work on what we're trying to find. Now, there's two parts to this. There's what we're going to do while we're saving, so we'll call this saving, and then we'll call this other part retirement. And the good thing is we know what our information is. We know that when we're retired, we want $6,500 per month. That's going to be our R value. So $6,500 is our R. We know that while we're retired, we're getting 4% per year compounded monthly. That means our I value is going to be 0.04 divided by 12. And we know we're going to retire for 25 years. So that means our N value is going to be 25 times 12, which I believe is 300. Now, because we're withdrawing money here, this needs to figure out, or we need to figure out, the present value of our annuity. Because when you withdraw money, you need money in the bank, and then you're going to take monthly payments of $6,500. When we do that, what's going to happen is we're going to have this formula that says, let me scroll down here a little bit. The formula is going to say A sub P equals R, which is your monthly payments, 1 minus 1 plus I to the negative N all over I. And we fill in our information. So we say 6,500 times 1 minus 1 plus 0.04 divided by 12 raised to the negative 300 all over 0.04 divided by 12. Now, you need to plug that into your calculator. If you have an 84, you're going to have to be kind of careful with your parentheses and so on and so forth. If you have an Inspire, make it look just like this. And when you do that, you get an answer of $1,231,441.14. This is your number. This is your number from like the ING commercial, and you have to save that much while you're saving to get to this point so that you can retire comfortably. So now what happens is this A sub P becomes our A sub F. We know that that's what we need to save up from right here. And so now we're going to talk about while we're saving. While we're saving, we know that we're trying to figure out how much we need to save, so we're trying to find R. We also know that we're saving for 40 years, so that's going to be 40 times 12, that's 480 months. And we know the interest rate at which we're saving is a little bit higher because we're, saving up and kind of gambling a little bit, but it's going to be 0.10 divided by 12. Now that formula that we're going to use is this right here. R equals I times A sub F over 1 plus I to the N minus 1. And when I plug in my information, I know that my I value is 0.10 divided by 12 times $1,231,441.14. That's a 4, by the way. All over 1 plus 0.1 divided by 12 raised to the 480 minus 1. And when I do that, I get an answer of $194.72. So if I can find these conditions, 10% compounded monthly for 40 years, all I really need to save is $194.72 per month for those 40 years, and that will allow me to have $6,500 per month when I retire for 25 years, and if I can find that interest rate of 4%. Finding the interest rate is the tricky part. All right. Now if we look at the second part, we're going to say, well, you decided working until 65 is not for you, and you really want to retire at age 55 or 30 years after working. And you still plan on living to 90, which means now that you're going to retire for 35 years. If you save at 15% per year compounded monthly and move your investments into an account averaging 5% per year compounded monthly, how much do you have to save to retire comfortably? So we're going to do this next problem on the next page. And we're going to do the same idea. First, we're going to talk about retirement. And the only thing that's changing with retirement, we still have an R value of 6,500, but our N value is now 35 times 12, which is 420 months. Our interest rate is also changed, and that's 0.05 divided by 12. And we got to find the present value. So what do? I say A sub P equals R 1 plus I, 1 minus 1 plus I to the negative N all over I. Plug in what we know, 6,500, 1 minus 1 plus 0.05 divided by 12 to the negative 420 all over 0.05 divided by 12. Again, plug that into your calculator and your number becomes $1,287,925.25. So that's my new number. That now becomes my A sub F, or the final amount that what I'm going to save at. We also know that we're trying to find R. Okay, we know that's equal to that. We know our interest rate is 15% now, so 0.15 divided by 12. And we know that we're saving for just 30 years, so 30 times 12, our N value is now 360. So let's use our formula. R equals I times A sub F over 1 plus I to the N minus 1. Plug in what we know. Slide down here real quick. 0.15 divided by 12 times $1,287,925.25 all over 1 plus 0.15 divided by 12 raised to the 360 minus 1, and that gives us a value of $186.03 per month. So if you only wanted to work for 30 years and can find an investment for 15% per year compounded monthly, you can save $186 per month. That will give you this much in your bank, and then that will give you 35 years of monthly payments of $6,500 given a 5% interest rate. So I hope that helps, and I hope that answers some questions about what to do when you're retiring and saving for retirement.